So definition says that obstruction offered to the flow of current by a conductor is called as resistance. So obstruction to the flow of current. Now we have seen flow of current is nothing but flow of charge. Okay. So when you say electric current flows, it means that electric charge is flowing. Okay. And in a wire, it is nothing but electrons. So these are ions. Okay. And in a metal, these ions are in a fixed place. And because of the thermal energy, they are just oscillating in their, vibrating in their own position. So because of their vibrations, they could cover more space than they actually can. And these electrons, which are randomly moving, they tend to collide with these atoms. Okay. So in this particular diagram, what you can see is electrons are randomly moving in all directions. So therefore, I'm going to write over here, the net flow is zero in any direction, any one direction. Okay, so if you want to ask that how many electrons are flowing in this direction, or what is the net flow of electron in that direction? So the answer is zero, because the electrons are flowing in random direction, all of them. Okay, so now what is the difference we have to make for the current to flow, electric current to flow? And the answer to that is one end of the wire is attached to a positive terminal and another end of the wire is attached to a negative terminal. So when you have one wire attached to positive end, another wire attached to negative end, the electron get a slight push toward the positive end. Okay, and therefore what happens? The net flow of electron is toward the positive end. And therefore we say that electric current is flowing. Okay, so sorry, electric current will be towards the positive, from positive to negative. Okay, so that will be the direction of electric current, but the electrons will be flowing toward the positive end. Okay, so when there is a potential difference between the two ends of the wire, electron flow toward the positive side. And as these electrons are flowing, they collide with the atoms or the molecules of the wire, and they lose energy. Okay, because of collision, they lose energy. And this energy that is lost is called as resistance. And generally in a metal wire, it is in the form of heat. So that is called as resistance, right? Now this resistance depends on length of the wire, okay? Length of the wire. So that means longer the wire, more will be the number of collisions, and thus more will be the resistance. This resistance is inversely proportional to the area of cross section. Okay, we can write that as pi r square as well. So area of cross section, or we can just say thickness of the wire. Okay, so that means if the wire is thicker, it will offer less resistance, and if the wire is thinner, it will offer more resistance. So basically, when you're talking about the cross section, the electron will have more space to go if the wire is thicker, and there are less chances of collision. And if the wire is thinner, there will be more chances of collision. Okay, there will be not enough space for the electron to go. Okay, it also depends on the material of the wire, directly proportional to L upon A. When you remove the proportionality sign and write an equal to sign, you multiply by a constant. And this constant is what depends on the material, okay, specific resistance or resistivity. So this is one formula, that resistance depends on the length of the wire, it depends on area of cross section of the wire, and it also depends upon the material of the wire, that is resistance or resistivity. There is one more factor that resistance depend on, and that is the temperature. So if the temperature of the wire increases, the vibrations of the atoms and molecule increases, and thus the collision also increases. Okay, but remember, this is for metals. There are materials like semiconductors which conduct better when the temperature increases. So in fact, the resistance decreases when temperature increases. We want to vary the potential and see how current varies, provided you don't change the resistance, the value of resistance. Okay, so how did he do that? So there is resistance This is a power source. Okay, this is resistance. Fine. So what Ohm wanted to do, he wanted to measure current. So to measure current, you need an ammeter. So this is an ammeter. He wants to measure potential. So this is a voltmeter for that. Okay, so we have current flowing over here. Okay, but what he wanted to do was to vary the potential, wants to change the potential. So to change the potential, he had a rheostat. So this is a rheostat over here. Okay, so this rheostat, when added, you know that by changing the position of this jockey, you can change the resistance and thereby control the voltage. So that is what Ohms did. And he then measured V against I. So he varied the voltage and he measured the current at the same time. So I'll give you some simple examples, like suppose the voltage was 5 volt and he observed the current to be 0.5. Okay, so then there was a voltage of 4 and he observed to be 0.4. Then there was 3 volt, the current was 0.3, 2 and 0.2, so on. Okay, so one thing which Ohms observed, that when he took the ratio of V upon I, that is 5 upon 0.5, he got it as 10. So this was coming constant. That means V upon I was a constant. So therefore, he got that V is proportional to I. Okay. And when you remove the proportionality sign, you multiply by a constant. And that constant, we call it as resistance. So when Ohms plotted this on a graph, he had current over here, which is in amperes, and he got the graph a straight line like this. Okay, so that is also an indicator that x and y axis are proportional to each other. And when he took the slope of this, so this is delta I, this is delta V. So how do you calculate slope? Is change in y upon change in x. So therefore, over here, he got this as 1 upon resistance. So for the Ohm's law, what do you need to know? You need to know the diagram. What is this diagram? Diagram to verify Ohm's law. Okay. The second thing that you need to know is the statement of Ohm's law or the definition of Ohm's law. So that according to Ohm's law, the current flowing in a conductor is directly proportional to the potential difference applied across its end, provided that the physical condition and the temperature of the conductor remains constant. So this thing is also called as limitations of Ohm's law. That means the physical state of the conductor and the temperature of the conductor should remain unchanged. So basically what they are saying, that this conductor or this resistor, its physical state means its dimensions, the length, the thickness should remain unchanged. Its temperature should remain unchanged. And then V will be proportional to I. Okay. And then you have the definition of resistance also. So over here we have R equal to V upon I. So when I is equal to 1, this is equal to 1 ampere, R is equal to V. So how do you define it? The resistance of a conductor is numerically equal to the potential difference applied across its end for the flow of unit current. So when the current flowing is 1 unit, the resistance is numerically equal to the potential difference. Okay, so these are the things which are important. And also another fact that is important is how do you calculate resistance from a VI graph? So if this is voltage and this is current, how do you calculate resistance? So one answer that is accepted is slope of a VI graph. The second accepted answer is delta V upon delta I. Okay, so remember, if you write, how do you calculate resistance? Resistance is V upon I. That answer will not be correct. You have to write delta V upon delta I. Okay, delta, I hope you remember, it is change. So that is how you calculate the resistance. So resistors which obey Ohm's law are called as ohmic resistors, and resistors which do not obey Ohm's law are called as non-ohmic resistors. Okay, so the one which obey Ohm's law, how do you know that they obey Ohm's law? The VI graph is a straight line for them. So for an ohmic resistor, the VI graph is a straight line. For a non-ohmic resistor, the VI graph is a curved line. Okay, so that is not a straight line, but it is a curved line. So what you need to remember is there are certain diagrams given in the book, which are not so much a part of your syllabus, but again, from your school exam point of view, I'm saying. So this is filament of a bulb. Okay, what you need to see is the resistance is increasing. Okay, here you can see that the resistance increases with increase in voltage. And then for a semiconductor like this, so this is a junction diode, which is nothing but a semiconductor. So for a semiconductor, you can see that the resistance decreases. Again, not a part of the syllabus, but only thing that according to the syllabus you need to know is for an ohmic resistor, the graph is a straight line, and for a non-ohmic resistor it's a curved line. It's not a straight line. Okay, and you need to know the examples for that as well. If you have a wire, say of copper, of a given thickness and a given length, and its resistance is 5 ohms. So if you take another wire, same thickness, same material, but the length is 2L, then the resistance will be 2 times 5, that will be 10 ohm. Okay, so remember, this is one wire and this is another wire of double the length. Okay, now if the same question is asked to you in a different way, like if you take another wire, double the thickness, okay, that means you have the same length, but you have double the thickness, then the resistance will be 5 upon 2, that will be 2.5 ohms. Okay, so this is one type of question. Another type of question that you need to know is if you have a wire, okay, like this, and you stretch that wire. So it is the same wire, but it is stretched to 2 times the length. So remember the difference. Earlier there were 2 different wires, and this is the same wire which is stretched to 2 times the length. Now this resistance will be 2 squared of the original. So that will be 20 ohms. Okay. If the same wire is stretched to 3 times the length, 3 squared, that will be 9 into 5, 45 ohms. So the same wire, when stretched to 2 times the length, it becomes 2 squared times. And when it is stretched to 3 times the length, it becomes 3 squared times. Now, why does that happen? Because the length becomes 2 times and the area of cross section becomes half. So you have resistivity, length, and area of cross section. So this goes up, and that will make it 4 times the resistance. If you are stretching it to 3 times the length, the area of cross section will become 3 times. And that will make it 9 times. So if one wire has resistance R, and that wire is stretched to n times, okay, 2 times, 3 times, 4 times, if that wire is stretched to n times, then its new resistance will be n squared times the old resistance. In the same way, if the wire is made smaller, that means a wire which is this way is squashed and it is made into half its size. Okay, so the wire is squeezed to make half its size, then the new resistance will be 1 upon n squared times that. Okay, so just to give you an example, if this wire has a resistance of 16 ohms, this wire will have a resistance of 1/4 of 16, that is 4 ohms. Okay, so the wire is made half of itself.